Hello students. Today we will start with the chapter Electrochemistry. As the name of the chapter, you can see electro. Electro means something related to electricity. The chemistry related to electricity, electrochemistry. So electrochemistry is the branch of science which deals with interconversion of electrical energy electrical energy and chemical energy. Now, either electrical energy will be converted into chemical energy or chemical energy will be converted into electrical energy. So depending on that, there are two kinds of cells: electrochemical cell and electrolytic cell. Electrochemical cell converts chemical energy into electricity. That is electrical energy. Electricity is also one kind of energy. Whereas electrolytic cell, it converts electrical energy into chemical energy. You know, there are various reactions which cannot take up by themselves, and we can make them occur by using electricity. So electrolytic cell uses electrical energy to bring about a chemical reaction. Electrolytic cell uses electrical energy to bring about the chemical reactions. For example, you know, gold is so much expensive. So silver jewelry or the jewelry made up of any metal that is electroplated with gold by using this electrolytic cell, so that the jewelry looks like that it is made up of gold. But actually it is not made up of gold. It is having only a layer of gold. And that can be done only and only with the help of electrolytic cell. So we will discuss them one by one. First of all, let us see about electrochemical cell in detail. You must have observed in your class 10 about the reaction of copper sulfate and zinc. In a test tube, you take copper sulfate solution. You know, copper sulfate solution is blue in color. And you put some pieces of zinc metal. In this, you put some pieces of zinc metal. Zinc metal is grayish white in color. What you will observe after some time, that the blue color of the solution fades away. Blue color of the solution fades away. And some brown precipitate are deposited. So what must has happened during the reaction? Copper sulfate will react with zinc metal. And as you know, zinc metal is more reactive than copper. So zinc will displace copper from the zinc sulfate uh, to form the zinc sulfate and copper metal. Due to the formation of zinc sulfate, the blue color of the solution fades away and finally it changes to colorless. And copper metal is brown in color. So copper metal is formed, because of which we are saying that some brown precipitates are deposited. And one more thing, test tube becomes hot. Test tube becomes hot means the reaction is exothermic because energy is released during the reaction. So here, chemical energy is converted into heat energy. So scientists thought, if in this reaction chemical energy is converted into heat energy, then by somehow process we can also convert this chemical energy into electrical energy. All of us know what is electricity. Electricity is nothing. Electricity is the flow of charge. So if you see this reaction in detail, what has happened actually, from copper sulfate, actually copper ions are reacting. And these copper ions, they react with zinc to form zinc ions and copper. So what has happened here? Zinc can be converted into zinc ions only with the loss of 2 electrons, because there are 2 positive charges. It means 2 electrons are lost. These 2 electrons are taken up by copper ions. And these copper ions are converted into copper. And in any reaction, as many electrons are lost during oxidation. The first one reaction is oxidation. Oxidation means loss of electron. And reduction means gain of electron. So if you see this reaction, 2 electrons are produced during oxidation and those same 2 electrons are consumed during reduction. Now you can add the 2 equations, zinc plus copper ion, to give zinc ions and copper. So you can see here, there's a transfer of electron from zinc to copper ion. And there is direct transfer of electron. That is why the chemical energy is converted into heat. And if these electrons, they can be made to go from zinc to copper ions with the help of some metallic wire, then the same chemical energy can be converted into electricity. So by using this idea, scientists made a cell, that is electrochemical cell. In that cell, there are 2 compartments. We have taken 2 beakers. In one of the beaker, we are taking zinc electrode. What is meant by an electrode? Electrode is nothing. Electrode is some element. Element may be metal or non-metal, along with its ions. So we are taking zinc electrode. Zinc electrode means zinc rod. This is zinc rod. In contact with its ions. अब ions तो अपने आप आ नहीं सकते. Ions को लेने के लिए हमें कोई उस metal का salt solution लेना पड़ेगा. Maybe any salt solution like zinc sulfate, zinc carbonate, zinc nitrate, which is soluble in water. So we have taken zinc sulfate solution at 1 molar concentration. Why 1 molar? We have taken the standard conditions. Similarly, copper electrode. For copper electrode, we have taken a copper rod along with copper ions. So in the same way, you have to take some salt of copper and you have to dissolve that copper salt in water. So let us say we have taken copper sulfate solution here. And here also we have taken the concentration 1. Now we have connected them with the help of a galvanometer. You know, galvanometer tells us about the direction of the current. So this is the experimental setup of simple galvanic cell, voltaic cell, whatever you can say. Voltaic cell or galvanic cell. Now, what happens? You know, this zinc electrode, it will act as anode. I will be telling you later why it is acting as anode and this copper is acting as cathode. Why not the opposite one? And you know, at anode, what happens? Oxidation. And at cathode, what happens? Reduction. Oxidation means gain of electron. Oxidation means loss of electron. Reduction means gain of electron. So what happens? At anode, zinc will be oxidized into zinc ions with the loss of 2 electrons. जितने इलेक्ट्रॉन्स लूज होते हैं उतने ही पॉजिटिव चार्जेस आ जाते हैं क्योंकि किसी भी मेटल में हमेशा इलेक्ट्रॉन्स और प्रोटॉन्स का नंबर इक्वल होता है तो अगर 2 इलेक्ट्रॉन्स लूज कर दिए तो 2 प्रोटॉन्स एक्स्ट्रा होने की वजह से देयर इज 2 प्लस चार्ज नाउ दीज 2 इलेक्ट्रॉन्स they go through this wire so this is the direction of flow of electron from anode to cathode now these electrons then they reach at cathode and at cathode what happens the copper ions present in the copper sulfate solution they take up those 2 electrons and get converted into copper atoms. So what happens with the passage of time? As you can see in the anode half, zinc is continuously converted into zinc ions. So what will happen in this compartment? The concentration of zinc ion will increase. And side by side, what will happen in the copper compartment? Copper ions, because they are converted into copper. So what is left behind? Sulfate ions. So here sulfate ions concentration will increase with the passage of time. So a time will come when there is such a high concentration of zinc ion in the zinc compartment and such a high concentration of sulfate ion in the copper compartment that the movement of electron will stop and the electricity will not be produced. Why? You know, at zinc electrode, electrons are produced and zinc ion concentration is so much high. Zinc ions are positively charged, electrons are negatively charged. So, high concentration of zinc ions in this compartment will not allow electrons to go in the outer circuit. And by chance, if the electron goes into the outer circuit, what will happen at this copper compartment? There is high sulfate ion concentration. Sulfate ions are negatively charged. Electrons are also negatively charged. So electrons will not be accepted. So the flow of current will stop. To avoid this, to get the continuous supply of current, we have to make certain change in this cell, and that is the introduction of the salt bridge. We will introduce salt bridge in this cell. Now, what is this salt bridge? Salt bridge is nothing. It is a U-shaped glass tube. Let us see. What is salt bridge? It is a U-shaped glass tube filled with a semi-solid paste, just like your toothpaste, semi-solid paste of agar-agar. Agar-agar is an organic compound which is generally used to make the paste, and some strong electrolyte. Strong electrolyte, it can be any strong electrolyte, KCl, or you can use K2SO4 or any strong electrolyte. So when we have introduced salt bridge, what has happened? You can write it as function of the salt bridge. First of all, you can see the circuit is completed. Otherwise, the circuit was not complete. The first function, that is, salt bridge completes the circuit. And the second thing, it maintains the electrical neutrality of the two compartments. Of the two compartments. See how. In zinc compartment, there was high concentration of zinc ion. Suppose you have used KCl as the electrolyte. Strong electrolytes, they get dissociated into ions completely. So by default, chloride ions will go to the zinc compartment and they neutralize zinc ions as zinc chloride. And in the copper compartment, there was high concentration of sulfate ion. So by default, potassium ions will go to that compartment and they neutralize sulfate ions by the formation of potassium sulfate. So once the two compartment solutions are neutralized, there will be the continuous supply of current. So this is how a cell works. So you can see the direction of the flow of electrons is always from anode to cathode. And the direction of the current is just opposite to the direction of electrons. So please keep in mind the direction of current will always be from cathode to anode. Sometimes a question is asked, what are the carriers of current in outer circuit and in inner circuit? Outer circuit means this area, this wire. Inner circuit means salt bridge. So if you know the meaning of outer circuit and inner circuit, you can very easily give the answer. So in outer circuit, electrons are the carrier of current, whereas in inner circuit, ions, cations and anions are the carrier of current. Inner circuit, ions, that is cations and anions are the carrier of current. Galvanometer tells us about the direction of the current. If you have seen the galvanometer, there is a scale like this. In the center, here is the pointer. When the galvanometer is not working, it is at 0. There are the readings on the left side as well as on the right side. So if the pointer moves in this direction, it means the direction of the current is towards this side. If the pointer moves towards this, then direction of current is this. Here in this particular case, the galvanometer shows deflection towards this side, showing that the direction of the current is from cathode to anode. And this particular zinc copper cell, it has a cell voltage of 1.1 volt. सेल वोल्टेज भी कहते हैं हम इसको, सेल पोटेंशियल भी कहते हैं, सेल वोल्टेज और सेल पोटेंशियल और ईएमएफ ऑफ द सेल. So here the cell voltage, it is written by E cell. And if it is standard conditions, like we have taken here 1 molar concentration, a temperature 298 Kelvin, pressure 1 bar, in that case, it will be E naught cell. Naught shows standard conditions. So the cell voltage of this particular cell is 1.1 volt. Now, how this E naught cell is calculated? This E naught cell is calculated by the formula E naught cathode minus E naught anode. E naught cathode and E naught anode, these are the standard electrode potential values. E naught value means standard electrode potential value, which will be given to you in the question paper. So once you have found out which one is anode, which one is cathode, and these values are given, like in this particular case, E naught of copper, I will tell you why this is written like this. E naught of copper is 0.34 volt and E naught of zinc is minus 0.74 volt. So you can put down the values here. Here cathode is copper, as you have seen earlier also. Anode is zinc. Just put down the values in this formula. Cathode 0.34 minus, sorry, it is 0.76. 0.76. So it comes out to be how much? 1.1. So this is how you can show how the standard electrode potential of the cell is calculated. Now, what is the meaning of E naught of cathode and anode? You know, any electrode, it can undergo oxidation, it can undergo reduction. But it depends that the given electrode is joined with which electrode to make the cell. For example, here we have connected zinc electrode with the copper electrode. Then we see their E naught values. The electrode having more value of E naught, like here you can see the electrode having more value of E naught, that is copper, will always have a tendency to undergo reduction. That has a strong tendency to undergo reduction as compared to other one. So the other one electrode which is having lesser value of E naught will always undergo oxidation. Keep in mind. So if suppose a single electrode is given to you, like say zinc electrode, and you are asked whether it will undergo oxidation or reduction. So what you will say? You will say that as it is, I cannot tell anything about that. First of all, I have to make the cell by using the given electrode with some other electrode, and then only I can tell you whether that given electrode will undergo oxidation or reduction by comparing the E naught values. Now these E naught values, actually these are their standard reduction potential values. You can see here how I have written Cu2 plus slash Cu. How Cu2 plus is converted into copper? By gaining 2 electron. So if E naught value is written like this, in general we also write like this, it means these are the standard reduction potential values. And suppose I am asked to find out its standard oxidation potential value. So how will I write? E naught copper slash copper 2 plus value will remain the same. Just I have to change the sign. So it will become minus 0.34. Similarly, I have been asked the standard oxidation value of zinc electrode. So I will just change it, zinc slash zinc ion, because zinc is converted into zinc ion with the loss of electron, and that is known as oxidation. So I will just change the sign. Plus sign को आप लिखो या मत लिखो, one and the same thing, 0.76. But while doing calculations, whether a given electrode is undergoing oxidation or it is undergoing reduction, according to the formula, we always use their standard reduction potential values. So from this discussion, you must have understood why I have shown zinc as anode undergoing oxidation and copper as cathode undergoing reduction. Because the electrode having lower value of standard electrode potential will always undergo oxidation, will always act as anode. And the electrode having more value of standard electrode potential will always undergo reduction and will act as cathode. This was the cell diagram, and keep in mind in the cell diagram, whenever we draw the cell diagram, we always show anode half on the left side and cathode half on the right side. अगर आपने उल्टा बना दिया, कैथोड को लेफ्ट पर बना दिया, एनोड को राइट पर बना दिया, then it will be wrong. Now here you can see copper is acting as cathode because the standard electrode potential of copper is more than that of zinc. Now let us take one more example where I make a cell by using copper electrode and silver electrode. And I am telling you E naught values first so that you can yourself decide which one will be acting as anode and which one will be acting as cathode. E naught of copper, as I have already told you, it is 0.34 volt, and E naught of silver, that is 0.80 volt. So from here, you can very easily decide. Obviously, copper has less value of standard electrode potential, so it will act as anode and silver will act as cathode. So I can very easily draw a cell. यहाँ पर मुझको एनोड दिखाना है. एनोड क्या है? कॉपर. कॉपर इलेक्ट्रोड. Copper electrode means copper rod along with copper ions. For that, we have taken any salt solution of copper sulfate solution at 1 molar concentration. Similarly, silver electrode, we have taken silver rod in contact with silver ions. You can take any salt of silver which can produce silver ion. Let us take silver nitrate solution at 1 molar concentration. We combine them with the salt bridge to complete the circuit, and we can combine these two electrodes with the help of galvanometer. Galvanometer shows the direction of current. In this case also, galvanometer shows the deflection towards this side. It means current is moving to this side. और आपको पता है current हमेशा move करता है from cathode to एनोड। तो यहाँ से भी आपको पता चल रहा है कि सिल्वर इज कैथोड एंड कॉपर इज एनोड. So, and the direction of electrons is always opposite to the direction of current. So, electrons will move from anode to cathode. And from these symbols only, you can very easily write the reactions. What has happened at anode? At anode, copper, you can see copper is converted into copper ions. Because, anode, at anode oxidation takes place. So, copper is converted into copper ions with the loss of electrons. And at cathode, what will happen? You can see from here, silver ion is converted into silver. Here you can see there is only 1 plus charge. So how many electrons it will use? Only 1 electron for converting into silver. But as many electrons are lost during oxidation, so many electrons should be gained. So for gaining 2 electrons, you need 2 silver ions. So multiply this equation by 2. Now you can cancel these electrons and now you can write the final equation, copper plus 2 silver ion to give copper 2 plus ion plus 2 silver. Ionic reactions should be balanced atom wise as well as charge wise. When we balance the ionic reactions, we always see that the total charge on the reactant side should be equal to total charge on the product side, no matter the charge is present on which ion. इससे कोई फर्क नहीं पड़ता, बस आपको ये देखना है कि रिएक्टेंट साइड का टोटल चार्ज प्रोडक्ट साइड के टोटल चार्ज के बराबर होना चाहिए. This you must have studied in class 11 also in the chapter redox reaction. And how much current is produced? For that, you will replace the galvanometer with voltmeter. Voltmeter will give you the reading like this here. What reading you will get in the voltmeter, that you can calculate also. Voltmeter will give the same reading. E naught cathode minus E naught एनोड. कैथोड यहाँ पर क्या है? सिल्वर. सिल्वर का इलेक्ट्रोड पोटेंशियल 0.80 माइनस 0.34. तो आप सब्ट्रैक्ट करिए इसमें से, ये आ गया 6 और ये आ गया 4. तो यू विल गेट ए करंट ऑफ 0.464. Here the voltmeter will show this value only. Voltmeter tells you the value of E naught cell, that is the cell potential, cell voltage, EMF of the cell. Galvanometer tells us about the direction of the current. So here also you can see you have, in this case, you have shown the copper electrode on the left side because copper is undergoing oxidation, and silver electrode on the right side because silver is undergoing reduction. I think all of you must have understood this, how we draw the cell diagram. Now the next thing comes, that is the cell representation. Cell reaction also I have told you. Now the cell representation. In cell representation, always keep in mind, we show anode half first and then cathode half. How we show this? अब यहाँ पर आप देखिए एनोड हाफ में क्या हो रहा है? कॉपर इज कन्वर्टेड इनटू कॉपर आयंस. सो फर्स्ट ऑफ ऑल you will show copper, then you will put a slash. Slash means interface. Copper solid है, copper ions aqueous है. Copper slash copper ion along with the concentration. जो भी concentration given है, अब यहाँ पर हमारे पास 1 मोलर concentration है तो हम 1 मोलर. उसके बाद हमें दिखाना है salt bridge. For showing the salt bridge, we show the double vertical line. Double vertical line means salt bridge. Then we show the cathode half reaction. In cathode half, you can see silver ion is converted into silver. So first of all, I will write silver ion. And whenever we write ion, we have to show the concentration. तो here again the concentration is 1m, या जो भी दी हुई है वो आपको लिखनी है. Then slash means interface. Silver ions क्योंकि aqueous है और silver solid है. So this is the cell representation. This is anode half where copper is converted into copper ion. So copper slash copper ions along with the concentration. Then double vertical line is meant for salt bridge. After that, you have to show the cathode half reaction where silver ion here in this particular case is converted into silver atoms. So silver ions along with the concentration, whatever concentration is given, slash silver. This is how to do the cell representation. And always keep in mind, whenever we represent the cell, we never use these balancing coefficients. We only use the symbols of ions and the atoms. We never use the balancing coefficients. Balancing coefficients का use Nernst equation में होगा. That I will be telling you later on. Now here we are talking about standard electrode potential, E0, E0 anode, E0 of copper, E0 of silver, E0 of zinc. So ये standard electrode potential, how do we find out the standard electrode potential of a given substance, of a given element, of a given metal, or of a given non-metal? Standard electrode potential means the tendency of that electrode to undergo either oxidation or reduction under standard conditions. As I have told you already, any electrode can undergo either oxidation or reduction depending on with which other electrode we have combined with that given electrode to make the cell. In zinc copper cell, copper was undergoing reduction and was acting as cathode. But here in copper silver cell, copper is undergoing oxidation and it is acting as anode. So from these two examples, you must have observed that any electrode can undergo either oxidation or reduction. Depend करता है कि किस दूसरे मेटल के साथ ज्वाइन करके हमने सेल बनाया है. जिस मेटल का स्टैंडर्ड इलेक्ट्रोड पोटेंशियल वैल्यू कम है, that will always undergo oxidation, will act as anode, and the other one electrode having higher value of E0 will act as cathode and will undergo reduction. Now let us see how to find out the standard electrode potential of any given electrode. अब स्टैंडर्ड इलेक्ट्रोड पोटेंशियल निकालने के लिए मान लीजिए हमें जिंक इलेक्ट्रोड दिया हुआ है. जिंक इलेक्ट्रोड मींस जिंक मेटल along with its ions. So for finding out standard electrode potential of any given electrode, we have to make a cell by using that electrode with standard hydrogen electrode. We have to make a cell by using that electrode with standard हाइड्रोजन इलेक्ट्रोड, जिसको हम नॉर्मल हाइड्रोजन इलेक्ट्रोड भी कहते हैं, स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड. इन शॉर्ट इट इज रिटन एज SHE, and if I am writing it as normal hydrogen electrode, then it is NH. Now what is this standard hydrogen electrode? Let us see the construction of standard hydrogen electrode. We will take a glass vessel. Here it is the platinum wire. At the end of the platinum wire, there is a platinum foil and it is coated with platinum black. Platinum foil coated with platinum black. You know, platinum metal is least reactive metal. It does not participate in the reaction. It is just acting as a medium for the transfer of electron. Now this platinum foil, it is dipped in 1m HCl. Means hydrogen ion concentration is how much? It is 1m. 1m concentration is taken as the standard concentration. Here we put a glass cover and through this glass cover, we pass hydrogen gas at 1 bar pressure, standard pressure, 1 bar pressure. And why we are using this glass cover? So that the hydrogen gas comes in contact with hydrogen ions. Hydrogen ions are coming from HC. So this is the construction of normal hydrogen electrode. As I have told you, any electrode can undergo oxidation as well as reduction. Depends with which other electrode we have combined it to make this happen. When this hydrogen electrode acts as anode, means when at this electrode oxidation takes place, then what is the reaction? Hydrogen is converted into hydrogen ion with the loss of electrons. You know, hydrogen ion is H plus, and if there is 1 plus, obviously there will be 1 electron. But you can see hydrogen gas exists as H2. अब हमें इसे balance करना है. There are 2 hydrogen, so we will put here 2. यहाँ पर 2 लगाने से there is 2 plus. So to balance the charge, we will put here 2. On the reactant side, no charge. On the product side, 2 plus and 2 minus will cancel, 0 charge. So this reaction will take place when hydrogen electrode acts as anode. And when it acts as cathode, then what will happen? Just opposite of this reaction. Just opposite. 2H plus 2 electrons, they are converted into hydrogen gas. So this I have shown you about the normal hydrogen electrode. Our topic was how to find out the standard electrode potential of any given electrode. So for that, what we have to do? We have to make a cell by using that electrode with standard hydrogen electrode. Suppose अब हमें जिंक इलेक्ट्रोड का स्टैंडर्ड इलेक्ट्रोड पोटेंशियल निकालना है, तो हम इसको क्या करेंगे? जिंक इलेक्ट्रोड के साथ कंबाइन कर देंगे. Let us make the zinc electrode. What is zinc electrode? अभी आपको बताया, any zinc electrode means zinc rod, that is zinc metal, along with zinc ion concentration. For zinc ion concentration, I will take any salt solution of zinc. And concentration should be 1m because we are talking about standard conditions. Internally, we will join them with the help of salt bridge. To complete the circuit and to maintain the electrical neutrality. And in the upper circuit, first we can use the galvanometer, because galvanometer will tell us at which electrode oxidation is taking place, at which electrode reduction is taking place. Here in this particular cell, what is observed? That galvanometer shows deflection towards this side. It means this is the direction of the current. गैल्वेनोमीटर हमें डायरेक्शन बताता है करंट की, और मैंने आपको पहले बताया था करंट ऑलवेज फ्लो फ्रॉम कैथोड टू एनोड. From galvanometer we have come to know about the direction of current. So definitely here the hydrogen electrode is acting as cathode, and obviously the other electrode, that is zinc, will act as anode. So direction of current will be what? From anode to cathode, that is from zinc to normal hydrogen electrode. So now what will be the reaction, that you can also decide, because you have come to know that which electrode is anode, which is cathode. अब zinc anode है, तो anode पर zinc का क्या हो जाएगा? Oxidation. Oxidation means loss of electron. So zinc is converted into zinc ions with the loss of 2 electrons. These 2 electrons will go from anode to cathode. And as I have told you, when hydrogen electrode acts as cathode, so what is the reaction taking place? 2H plus ions plus 2 electrons to give you hydrogen. And now you can write the final equation. So these 2 electrons will cancel. Final equation will be zinc plus 2H plus ions to give zinc ions plus hydrogen. Now when we replace the galvanometer with voltmeter, we replace this galvanometer with voltmeter. Voltmeter tells us about the cell voltage. So here the cell voltage, that is E naught cell, it comes out to be minus 0.76 volt. Sorry, E naught cell, it is 0.76 volt, not minus. Our aim was to find out the standard electrode potential of zinc. Now apply the formula. E naught cell is equal to what? E naught cathode minus E naught anode. And you have found out already by using galvanometer that zinc is acting as anode. It means you need to find out this E naught anode. And E naught cell, you know, that is 0.76 volt. And keep in mind, the standard electrode potential of hydrogen electrode, which is written like this, it is always 0. By convention, the standard electrode potential of hydrogen electrode is taken as 0. So आप values put करिए, 0.76 is equal to 0 minus E naught A. तो E naught A आपका कितना आ गया? E naught A is minus 0.76. अभी हमने पहले न्यूमेरिकल किया था, उसमें आपने यही वैल्यू यूज की थी, minus 0.76 volt. So this is how the standard electrode potential of any given electrode is found out. Cell reaction I have told you. Now the left out thing is cell representation of this cell. For cell representation, you know, here first of all we write anode half, then we show cathode half. Anode half में आप देखिए zinc is converted into zinc ion. It is very easy to write the cell representation. Zinc slash zinc ions along with its concentration 1m या जो भी given है. उसके बाद हमने salt bridge लगाना है, double vertical line. उसके बाद हमें cathode reaction में देखिए आप, H plus ion is converted into hydrogen gas. Balancing coefficients को use नहीं करना, मैंने आपको पहले ही बता दिया है. H plus ion along with its concentration 1m या जो भी दी हुई है. फिर slash hydrogen gas फिर उसके बाद आप स्लैश भी लगा सकते हैं या सेमी कॉलम भी लगा सकते हैं, प्लैटिनम। ऐसा क्यों लिख रहे हैं हम प्लैटिनम? बिकॉज हाइड्रोजन गैस इज कमिंग इन कॉन्टेक्ट विद H plus ion only through platinum. Platinum itself is not participating in the reaction. It is just acting as a medium to bring hydrogen in contact with hydrogen ions. Similarly, any metal is given to you and you are asked to find out the standard electrode potential, you can very easily find out. First, you have to make the cell by using that given electrode, by combining it with normal hydrogen electrode. First of all, use the galvanometer to see the direction of current. उससे आपको ये पता चल जाएगा which electrode is acting as cathode, which electrode is acting as anode. And after that, you can replace galvanometer from the circuit with voltmeter. Voltmeter will give you the cell voltage, and from that cell voltage, you use the formula E naught cell is equal to E naught cathode minus E naught anode, and you can find out the standard electrode potential of any given electrode. This is the formula when the conditions are standard. But if the conditions are not standard, then what you will do? Suppose concentration is not 1 molar, it is something other like 0.01 or 2m or 3m. So in that case, this formula E naught cell is equal to E naught cathode minus E naught anode, that will not be applicable. For that, we have to use some other formula, and Nernst was the scientist who gave one formula, who derived one formula. In this video, I will just tell you the formula, its derivation, and its use that we will discuss at some other time. And what is that? E cell. E cell means under given conditions, means those conditions are not standard. E cell is equal to E naught cell minus 2.303 RT upon NF log concentration of products raised to the power equal to their balancing coefficients. Let us say it is X divided by concentration of reactants raised to the power equal to its coefficient, balancing coefficients as shown in the balanced chemical equation. Let us say it is Y. E naught cell you can find out by the formula E naught cathode minus E naught anode. R आपको पता है, it is 8.314 joules per Kelvin per mole. Temperature T, it is 298 Kelvin. F, Faraday, 1 Faraday is equal to 96,500 coulombs. If we see the exact value, then it is 96487 coulombs. N is the number of electrons getting transferred from oxidation half to reduction half. Now in this you can see R is fixed, temperature is fixed, this value is fixed. If we put down all the values in this, then this formula gets simplified to E cell is equal to E naught cell minus 0.059 upon N log concentration of products raised to the power X divided by concentration of reactants raised to the power Y. And these X and Y are the balancing coefficients of the corresponding things. That is all for today. New things, next things that we will see in some other video. Thank you.